Okay, today in Algebra, we'll be covering CO6, writing, interpreting, and evaluating algebraic expressions. That's a lot of stuff all in one objective, but we can certainly do it. Two terms to define. What is an expression? Not a facial expression. Can't see those right now anyway with all the masks on, but a mathematical expression. How do we define it? Peter? An equation has an equal sign, and that's actually what the difference between an expression and an equation is. Okay, an equation, because it has an equal sign, has value, right? An expression is just a collection of terms. Another way to say that is a math statement. Okay, a math statement. An example of an expression would be like 6 plus 3, right? It's a collection of terms, 6 and 3, a math statement. It doesn't have value, okay? We can give it value. We can say 6 plus 3 equals 9, and now it becomes an equation, right? Now it becomes an equation. So an expression doesn't have value. It's just a statement. What is a variable? What is a variable?
A number.
A variable itself isn't a number. It represents a number, right? But what is a variable?
A letter that represents a number.
Usually a letter, but can also be a symbol, right? But it's an unknown in an expression or equation. As Drew said, it's usually a letter, most commonly X, N, Y, something like that. But it can also be a symbol. It can just be like an empty space, okay? But it's an unknown. It's what we're trying to find. In science, the variable is what we're changing, right? In an experiment, you have to list all the variables, things that can change, things that aren't constant, okay? So it's an unknown thing. All right, and what a lot of kids say, the reason why we're doing CO6 here is that a lot of kids say that word problems in math are the hardest. Okay, because you have to kind of develop your own expression, develop your own equation. What do you do? What's important? What can I ignore? All those different words. And so what we're doing today, and this table can go on a help sheet, is we are going to be throwing out some words or phrases that refer to each of the four major operations. That when you see them in a word problem, okay, you might have some background and say, okay, I know what this means, right? So give me a word or phrase that means addition, subtraction, multiplication, or division. You can pick any of the four. Yeah, Caleb.
Subtraction equals take away.
Okay, take away. Would go under subtraction, take away. What else? By. Okay. In the context of, rows of 8 by 4, right? 8 times 4, good. Yeah. And is kind of a tricky one because it kind of depends on what comes before that. If I ask you for the sum of 6 and 3, in that case it's talking about adding, right? Because the word sum there. The product of 6 and 3 would be multiplying. The quotient of 6 and 3. So and is really more of a connecting word, okay? It really depends on what comes before it. But we can put sum, S-U-M, sum, for addition. And I also mentioned product for multiplication. Fill those in there. Joey?
Subtraction less than.
Less than. Okay. Yeah?
Multiplication
Of. And I want to put the word groups in front because that's probably the most frequently used phrase, groups of. Okay? And then for division, that word groups can also be used for division, but if we're talking about putting things into groups, right? You're dividing something into groups or putting and then all usually follows that too. Okay? Peter.
Division quotient.
Quotients for division. Definitely. What else? Take a look at the page too. If you're kind of struggling, take a look at what comes down on the page and see if you can figure out, where those words or phrases, those are the ones that we're practicing. So where do those fall in this category, in this table? Drew?
Multiplication
Times. Sure. Okay. Yeah?
Division is divided by.
Divided by? Blake?
For addition, dot.
Sorry?
Dot.
Dot?
Dot.
Got. Use that in a sentence.
James got 10 pencils.
Okay, that's not really addition. That's more of a, just defining a quantity. Minus. Okay. The other one for subtraction that I want to make sure gets in here is the kind of a dual phrase, subtracted by versus subtracted from. Okay, subtracted by versus subtracted from, because the order there makes a difference. If I say 10 subtracted by 2, right? 10 subtracted by 2, that means 10 minus 2. If I say 10 subtracted from 2, 10 subtracted from 2, what expression does that give me? 10 subtracted from 2. 2 minus 10, right? So the order with subtraction, you've got to be very careful there. Less than is kind of the other one. 10 less than 2 doesn't mean 10 minus 2. Okay? 10 less than 2 means you're starting at 2 and taking 10 less than that. That would also be this bottom one here. So less than and subtracted by versus subtracted from. Make sure you pay very close attention to order when it comes to that. Yeah?
Division, half the difference.
Oh, sure. Half. Half or third or quartered. Okay? Divide by 2, divide by 3, divide by 4. You said the word difference. What category does difference go under? Yes, goes under subtraction. We're going to add that on here. Difference. How far apart two values are. That's what subtraction is. Any others for addition? I feel kind of bad for addition. All we got is the sum over there. Yeah. Add. Sure. Plus. Okay. Or added to is the proper way to say add there. Or plus. Perhaps total in the right context there. Total of 6 and 3 would be 9. Okay. So use this table to help you as you go through the page here. And we are running a little bit short on time, so we'll speed up a bit. But your homework is write the verbal phrase as an expression. Evaluate when n is 2. So there are 2 steps here, right? Write the verbal phrase as an expression. So you're going from the verbiage to the numerical, and then evaluate when n is 2. Pick one on here that you'd like to do together. Which one? Peter?
17 less than the product of a number and 9.
Okay, so 17 less than the product of a number and 9. I see that phrase less than there, so I just need to keep that in mind. That was one that we kind of starred up above. And I see product, which I know is we're multiplying. A number. What does a number refer to here in this context? Violet? A variable, right? An unknown. Okay? I'll use n. And of course we have 9. So 17 less than the product of a number and 9. I can write the product of a number and 9 as 9n. I wouldn't have to put the n first, even though it's written first, because you can multiply things in any order. Typically, that 9, let's call it a coefficient, will come first. Is this saying 17 minus 9n or 9n minus 17? Do you know? 9n minus 17. 17 less than the product, right? 17 less than the product. That comes second. And then I need to evaluate this when n is 2. So kind of like we did in the other exercise earlier, I'm replacing my variable with 2. 9 times 2 is 18. Minus 17, it equals 1. Okay, it equals 1. We did not get to do quite as many examples as I would have hoped. However, I am going to ask you to give this a shot tonight. You've got the first page here. The second page, I give you the numerical, and I'm having you go to the verbal. So your answers on the second page should look like the statements on this page, right? Okay. Second page, you're going from the numerical to the verbal. I do not grade on right and wrong, so as long as you've attempted it, given it your best shot, then you're fine. Okay, don't leave anything blank. No IDKs. Okay. You can email me if you've got questions on it. What day is today? Monday. Got nothing better to do tonight than watch football, so I'll have no excuse for not responding. Yes?
Did you have to do the world icon on the other side?
Yes, the real world. That is part of your homework as well. Both pages due tomorrow, as well as your math packet. So if you left it to the very last minute, then you've got a busy evening. Okay? That, folks, is how you math.
Don't forget